Hi, Year 9. Beginning with 7a, we're going to take a look at what index notation really means. So remember, index notation, an index is another way of saying an exponent or a power. So if I write something with an exponent or a power, it's this small little number. So for example, if I had the number x and then I square it, we call this 2 the index, and we call the base, this x, is our base. All right, so when we write something as an index form, we're writing it with a base and a little power, or a 2, or 3, or whatever the index happens to be. So another way of saying x squared is x multiplied, so times, and then x. So we have to make sure our x's are very curvy and the times is very straight, like a cross. So for example, if we were going to write the number 24 with index notation, what you might be asked to do is write down the prime factorization. So factorization means to multiply. So I'm trying to think of what numbers multiply to make 24. So I might start by saying, well, I know 6 times 4 makes 24. But if I want to write the prime factorization of 24, I need to keep breaking down my numbers, my factors, until I have prime numbers. And remember, prime numbers are only divisible by 1 and itself. So 6 is still divisible by a couple other numbers besides 1 and itself. So I'm going to continue to break 6 down into 2 times 3 times, and then the 4 I'm going to break down into 2 times 2. So if I multiply 2 times 3 times 2 times 3, I get back to 24. But 2, 3, 2, and 2, those are all prime numbers. So the way I can write those in index form is if I take my base of 2 and I realize that I have 1, 2, 3 2's. So 2 times 2 times 2, another way of saying that is 2 cubed. And I'm going to multiply 2 cubed by my other base, which is 3, but I only have 1 3. So I can write to the power of 1. And it's just like multiplying them. So 2 cubed times 3 to the first. You might also see this with brackets. So you might see 2 cubed in brackets, and then maybe you have a 3 in front of the brackets. That's just another way of writing the same index form, but without the cross for multiplication. So looking at example 1, if you're asked to write expanded form, that means you're going to be given the index form and I have to expand it. So on my paper, 5 to the 4th power would mean I'm multiplying 5, the base, by itself 4 times. So 5 times 5 times 5 and times 5. So I have 1, 2, 3, 4 5s. For example, let's look at C. If I have x, y, they're already multiplied by each other, raised to the 4th power. Again, I'm going to have xy multiplied by xy multiplied by xy multiplied by xy. So I really have 4 x's and 4 y's all multiplied by each other. Okay? Since I can multiply in different orders, I could also write all my x's, 1, 2, 3, 4, and then all my y's, and that would be the same thing. And if we don't see a sign, so there's no symbol between the x's, that also assumes we are multiplying. For example 2, says write each of the following in expanded form. So again, I'm going to have to expand what I'm given and then try to evaluate it. So if they're all numbers, that means I can simplify them at the end. So 5 cubed means I'm taking 5 times 5 times 5. So if I actually compute that, 5 times 5 is 25, times 5 is 125. Let's do one with negative numbers as well, because we always tend to throw off our negative numbers. So the reason why -2 is in brackets is because I'm actually going to include the negative as part of the 2. So -2 times -2 times -2 times -2. 1, 2, 3, 4. I need one more. It's inappropriate to leave times and minus signs next to each other, which is why you will notice that a lot of problems have the brackets around the -2. And that way we don't have two different operations right next to each other. We just have the times, and then we have brackets -2. So if I simplify this, -2 times -2, this makes 4. -2 times -2, that makes 4. So 4 times 4 is 16. 16 times -2 makes -32. So what I'm looking at here is I have 5 negative numbers. So if I have an odd power, my answer is also going to come out to be negative. Whereas if I took one of these -2's away, I would wind up with an even answer, or a positive answer, because I have an even exponent. Let's try one more. Let's try 2/5, and I'm going to raise 2/5 to the 3rd power. So that means I'm going to take 2/5 multiplied by 2/5 multiplied by 2/5. So we have to remember how we multiply fractions. So numerator times numerator. So 2 times 2 times 2 is going to give us 8. And then denominator times denominator times denominator. We did that one earlier. That's 125. So 8 divided by 125 would be our final answer. Our last example is going to go backwards into index form. So you're given expanded form, and I want to write it in index form. So 5 is our base, and then I just count how many times I repeat the 5, and that becomes our index. In part B, I have 6 as a base, and I only have one of them. And I have x as a base, and I have 1, 2, 3, 4 of them. So 6x to the 4th is how I would write my answer. For the last one, I have 4, and I have a. I have 1, 2, 3 4s. That becomes my index, and I have 3 a's. Since I have 3 of both, I could also say that I have 3 of 4 a's. And I would wind up with the same answer. I'll see you guys in class tomorrow.